Fourth grade into math lesson 8.2. Estimate product. I can estimate products using a variety of methods and predict how the estimated product will relate to the actual product. Spark your learning. Mr. Atkins has this problem on the board. For morning work, use the problem to answer the following questions. What might the unknown numbers be? So he got 250, right? What times something can get us 25? 5 times 5, right? Okay, so we could do 5 times 50, okay, because we know 5 times 50 would get us 250. What else could we use? If we dropped off the 0, that would be 10, right? Times what? 25, okay. So there could be different possibilities, correct? Yeah. Build understanding number 1. For all the 4th grade science centers, Mr. Atkins made 11 discovery boxes with 23 small objects in each box. About how many objects did he have together for the discovery box? Okay, so we need to pull out our numbers, 11, 23, and then about how many? About tells me that it's what kind of problem? An estimation problem, okay, because we're not getting an exact answer. So 11, is 11 closer to 10 or 20? Okay, so 10 times 23, is it closer to 20 or 30? 20. Oops. Okay, so put the 1 in a box, the 2 in the box. 1 times 2 is 2, and add 2 zeros. So about 200 objects, correct? Would our actual answer be a little bit more or a little bit less? A little bit more because we estimated downward, right? 11 went down to 10, 23 went down to 20. So how can you use rounding to determine a reasonable estimate for the number of objects Mr. Atkins gathered? So how does this help us? When we get our actual answer, will we know if it's close to that, then we're probably correct? Okay, so how can you use basic facts to find the estimate? So we actually already did that, didn't we? Okay, we took 1 times 2, got 2, and then added 2 zeros. Mr. Atkins had together about how many objects? 200 is what we came up with, right? How do the rounded numbers compare to the factors? How will this affect your estimate? We just talked about that, right? We rounded down, right? Okay, so our actual answer should be a little bit more or higher than our estimate, correct? Yeah. Okay. Step it out. Number 2, Mr. Atkins challenges the students to spend 45 minutes without electronics on each school day in November. For about how many minutes will each student be electronics free in November? So we need 45 minutes, and then we need to do each school day, right? Because does each school day make a difference compared to each day in November? Yes. Okay. So use the front end estimation. Oh, we forgot to say what we're looking for. And then we're using about. About tells us it's an estimation, correct? In what place value is the front digit in each number? So is it in the 1s, the 10s, the 100s? We only have 2 place values. So the front digit is in the 10s, right? Circle the 10s, then write the estimated factors, changing all the other digits to a 0. So we have a 1, right? The 9 is 5 or higher. So is it closer to 10 or 20? 20. The 4 is in the 10 spot. 5 is 5 or higher. So is it closer to 40 or 50? 50. So 20 times 50. So put 2 in a box, 5 in a box. 2 times 5 is 10, and add 2 zeros. Use rounding to estimate the same product. So Actually, guys, we did what they wanted right here. So this was the high. Remember how before we've done the high and the low? Okay, so they wanted us to round each one. So what would be the low? If we just kept them 10 and 40, right? So 10 times 40. So 4 and a 5, or a 4 and a 1. So 4 times 1 is 4, and add 2 zeros. Okay, so compare the estimates. Which estimate is more reasonable, the low or the high? The high, right? Because if we would have rounded to where they would have been the closest to, the high was closer than the low. Okay, so which one should we use? The high. So each student will be electronics free for about 1,000 minutes in November. Okay, so right here, let's put high because these estimates are closer to the actual answer. Stepping out, number 3, Mr. Atkins' students each make 8 origami animals. There are 27 students in his class. How can you use compatible numbers to estimate the number of origami animals the students make? Write compatible numbers for 27 and 8. So instead of going with 20 and 10, what are some numbers that are easy for us to multiply? Could we do 25 instead of 27? Yeah. And then it's not so far off, right? Instead of 8, could we use 10? Mm-hmm. Yes. So we could do 25 times 10. So put 25 in our box, 1 in our box. 1 times 25 is 25 and add a 0. So the students make about 250 origami animals. So how will this estimate compare to the actual product? So will it be more or less? More. It'll probably be more, right? Okay, because the 25 is just a little bit less, and then the 8 is a little bit more. So will it be too terribly far off? No, okay, but it should be a little bit greater, right? So compatible numbers are numbers that are easy to compute mentally. So of course, 25 and 10, all you have to do is add a 0, right? Check understanding. Estimate the product of 37 times 24 using each method. Okay, so front end estimation is you just use the highest place value, right? And that's the only thing you do. Do you change any of the other numbers? No, just the back. So 37 would be what? 30 times what's in our 10 spot. And our next one, 20, right? Or 2. So 3 times 2 is 6, and add 2 zeros. What about rounding? That's where you decide if it's closer to which tens, right? Okay, so 37, would it be 30 or 40? 40, it's closer to 40, times 24, is it closer to 20 or 30? 20. So 4 times 2 is 8, and add 2 zeros. Compatible number. What could you do 37? 40, okay, and what about 24? 25, right? Okay, so if I put 4 in a box, how many quarters are in a dollar? 4. So 4 times 25 is 100, right? And then add another 0. Okay, so number 4, which method for estimating would be most reasonable if you wanted to make sure You add 37 craft materials for each of the 24 students in art class. So which one would be the better choice? Okay, so rounding, that made us go up a little bit, but then down some. What about the compatible numbers? Did we go up on both of those?
Yes.
Okay, so even if we had a few materials left over, would that be better than not having enough for all the kids? Yes. Okay, so we would probably want to use the compatible numbers just to make sure we had enough to cover all the materials for all the kids. Should we also do that with money?
Yeah.
Yes. Okay, because if you want to go buy something and you don't bring enough money because you estimated too low, then are you going to be able to buy it? No. Okay, so number 4 would have been compatible numbers, would have been our better bet. On your own, number 5, use structure. Mrs. Hernandez is shopping for a new cell phone plan. She knows that she sends about 28 texts each day. The greatest number of days in any month is 31. How can she use estimation to help her decide which cell phone plan would be best for her? Okay, so what would we want to do? Do we want to do, can we just do the rounding?
Yeah, sure.
Okay, so 28, 31, and then which? So rounding. And then we would take what? 28, is it closer to 20 or 30? 30 times, is 31 closer to 30 or 40? 30. Now, why did rounding work here? We went up how many on 28? 2, and we only went down 1 on 31, right? So do they kind of counterbalance each other out? Yes. Okay. So put 3 in a box, 3 in a box. 3 times 3 is 9, and add 2 zeros. So what would be her best plan to pick? The basic, the extra, or the supreme?
The extra.
If she did basic, that's only 600 texts a month. Is that going to cover her 900 texts? No. So extra is only 800. So is that going to cover her 900 texts? No. So she needs what? She needs the supreme. So then she has a little bit of wiggle room if she wants to do more, right? So she needs the supreme plan. Number 6, reason. Bella decides to read for 45 minutes each day for 22 days. What is an estimate for the number of minutes Bella will read? Okay, so should we do rounding? Should we do front end? Or what should we do? Could we do just front end on this one? Okay, so let's follow our numbers. So 45, 22, and which one is the best one? So front end. So if I just do front end, that is the numbers in the 10 spot, right? So 40 times 20 equals, put 4, 2, what is 4 times 2?
4 times 2 is 8.
And add 2 zeros. So about
800 minutes.
Okay, so Ann wants to save $425 to buy a new video game system. He earns $15 each week for chores he does around his home. He estimates that if he saves his money for 24 weeks, he will have enough to buy the game. Do you agree with Ann? Why or why not? So he wants the $425, $15 each week, and he says it will take him about 24 weeks. So could I just do compatible numbers? Yep. Okay. So I could take 25, right? Because it's 25 close to 24.
Yeah.
Okay. And then what am I going to do here? Times, well, let's not do 15. Could I say 20? But this is money. So do we want to be on the high end?
Yeah. No.
We want to be on the low end. So let's do 10. So that would get